All right, we will continue our work on the supplemental problems in our 1.10 section with number 2. So on number 2 here, they tell us that a rectangle is inscribed in a circle with radius 2, and they give us a diagram. P is a point on the circle. Specifically, that point is in the first quadrant. That'll help us make sense of any sign issues, making both x and y positive. The one thing I want to just point out, there is a slight typo. This should be a function of x for part A and B. So we know that the area of this rectangle will be a product. I know that the area of a rectangle is length times width. And what I'll need to do is find both of these quantities in terms of x and y. Well, what I can see here is that the length, I can make it either one. Let's use our x direction here. That will be 2 times x. See that we need to include this x value as well as that one. We add them together to get our x's. Similarly, we will get 2y on the right-hand side for the width. So our area is the product of 2x and 2y. Well, as we see with a lot of these problems, we need to express this equation, this function in terms of a single variable. So we need to get rid of that y. Luckily, they give us a relationship between x and y. So what we'll do is we'll solve this equation, right? Y squared would equal 4 minus x squared. So y would equal the square root of 4 minus x squared. We can't simplify that much further, but we do now have the answer to part A. The area as a function of the x coordinate will be 2x times 2 times the square root of 4 minus x squared. Well, let me fix that. And we can simplify that one step further to get 4x times the square root of 4 minus x squared. On part B, they asked us to express the perimeter of the rectangle as a function of x. The perimeter here would be 4x plus 4y. And we can write that directly as a function of x now that we've solved in terms of y. We can write this as 4x plus 4 times the square root of 4 minus x squared. That is for part B. On part C and D, we are going to optimize these functions. So I'll leave that part to you. I'll just pause the video here and work this out and give you an answer about how best to solve. Hopefully you've taken the chance to test this out, grabbing your graphing calculator. For part C, we would graph the area function that we found in part A, and we're trying to find a maximum value. And that graph gives us a maximum value when x is approximately equal to 1.41, which exactly is the square root of 2. We find the same thing for part D. Hopefully this makes a little bit of sense. When this area and perimeter are maximized, it occurs when we have a perfect square. So when both x and y are equidistant, that will maximize our perimeter and our area. All right, that is number 2.